Okay, this is a series where we are going to build a vacuum tube guitar amplifier from start to finish. We're going to have an idea. We're going to put that idea into a schematic. We are going to build off that schematic, and then we're going to plug a guitar into it and rock it out, hopefully. All right, so let's see how it goes. Specifically, I had these tubes. I have tons and tons of tubes from God knows what, but I saw this 25 BQC GA tube right here, and I said, man, that would make a cool amplifier. So this guitar amp that we're building, it ain't the usual 6V6 or 6L6, so there isn't any literature out on it, and we will be forced ultimately to decide on the design ourselves. So let's dig into it if you're interested. We are going to use this Spectrum software download. This is the MicroCap 12 here that I'm using, and you can see. You do not have to use that at all. You could draw your schematic out if you wish. Do it any way you want. Use any program you might have already. For the power supply design, we are going to use this here, this PSU Designer 2. And so go ahead and download that. For our characteristic sheets on our tubes, we're going to use Frank Pocknet here. For a load line calculator, we're going to use this VTA DIY. This is the first time I've used this, and I love it. So I want to share with you what I found there. And this is just another resource. So I am not an electronics engineer, but I do believe this guy is here, Valve Wizard. He's in the UK. He has books out. Awesome reference. We may even have to go back and reference some of this stuff. So I'm a hobbyist, just so you know, and I have been building amplifiers since I was in high school. And I just want to share with you how I do it, my process, and hopefully you can build on that and make it your own. But let's get started. So today, what we're going to do is we are going to make the schematic for the power output, which is, again, this tube right here. This is our power output tube. So at the end of this video, I'm going to show you how we come up with this. And what we're going to use to get there is this, Frank Pocknet. So go ahead, pause, catch up, do what you got to do to get here. All right, and welcome here. So the tube we're using is a 25 6Q. I'm sorry, it's got a bunch of numbers. I already forgot. 25 BQ6GA. Now, in the tube world, there are tons and tons of equivalents. So you might not be able to find that tube. Oh, by the way, to find tubes on this, just click on what it starts with. In this case, a 2. Find the closest you can to the whole thing. In this case, 23 is where we're going to start. And then just scroll down and search. They used to have a search engine that you could use, but that no longer works. So this is what we're doing. And we'll scroll down till we find... Did I click on the right thing? Oh yeah, here we go. Next tab over. So here's the tube we have. 25 B6G. Oh, crap. That is not our tube. 25BQ6. This is a GT. We have a GA tube. It looks a little different. But this tube is the exact same as a 25CU6. And let's go look at that. Also note 25BQ6GT is the same as 6BQ6GT. And that's important for later on when we go into the load line calculator. So here's a 25CU6. And this has got the GA shape just like our tube. So let's take a look at this real quick. This is a schematic of a tube right here. We have the plate, 3 grids, the cathode, and the heater. And what they've done here is they've superimposed the schematic onto the tube socket, which is going to hold that in our chassis. Now, what we need to do is we need to start making our schematic, and we're going to label these electrodes, like the cathode, grid number 1, grid number 2. Grid number 3 we're not going to worry about. It's just connected to the cathode and the plate. So if you already downloaded the micro cap, let's go ahead and let's start building our schematic. I know this is going kind of fast, but there's a lot of information in these videos, and we're going to build on it as we go. So if you don't pick something up right away or it doesn't make a whole lot of sense, you'll probably get it later on down the road when we go more in depth. But for today, we are just going to make new schematic file, hit OK. Here we go. And what we want to do is we want to start off with a pentode. Now, quick note, you can start off wherever you want when you're designing a circuit. I happen to have this tube, and I thought it looked great, and I've used similar tubes before in a push-pull configuration, and it turned out amazing. So when I saw that I had this tube laying around, I was like, oh, I really want to do a single-ended amplifier, which is probably going to give us about 4 watts range, and we could fairly easily keep our cost to build a tube amp head here. Fairly easily keep it under about $180, including everything we need to get: our tube sockets, wire, all the component parts. So I thought that would be a good way to go. And then down the line, we'll have to consider building a box for it, the cabinet, and putting a speaker in so we can use it. But we'll get into that. Right now, go to File, and then left click. We already did that. I got to talking and messed it all up. Go to Component. Sorry. Left click. And then we're going to go to Find Component. Here, we can type in. Don't even have to type it all in. And we have pentode. This is what we want. Now, I keep the search field on name because if you change it, you see, it gives you a whole bunch of choices. And I don't want that. I want to get to my stuff quick and easy. So, pentode, OK. And I'm just going to put it right in the middle. Bam. Okay, so we have our pentode. The next thing we're going to do is we are going to go to component again, and we are going to find our load transformer. So this is going to be the transformer that takes the output of our tube and matches it to push a speaker. It's called the audio output transformer or impedance matcher. So let's just type in transformer. Over the meets the eye. Bam, transformer. This time, and there's going to be no value for it. We're going to figure out what the load is. We're actually going to do that in the next series or the next video. So once you got the transformer there, come on up to this field. See this little rotate button? Click that. Bam. And then come over here to this handy dandy select mode here in the left hand. I'm going to bring this K. This is ultimately we can use that with our transformer to, we can click on that and right when we figure out the load, what the load's going to be. Okay, so I'm just going to put the transformer over here. I want to give myself plenty of room. And while we're here, double click right on this X1, 25. And you can, depending on the tube you use, and I always forget this, B25BQ6 or BQC6. I'm just going to write 25. Well, I'm going to write 25 CU6. This is the tube that I want to use. All right. Now I'm just going to set this off to the side. And then the other components we need are resistor. You can either get it here or you can get it here. I'm going to take this one. We need an input resistor or the grid resistor. Okay. We need a cathode resistor. We don't know the value for these yet. We're going to do that in the next video. And then we need one capacitor. And this is going to be the cathode bypass capacitor. Put that there. We don't know yet. And we're going to need a ground. And we'll just put that to the cathode. All right. If you're not to this point, go ahead and pause and catch up. And then we'll go from there. So first thing you'll notice, compared to the pinout, I'll bring that up again, we don't have any of these tube socket pin numbers. So we need to put those in there. So let's do that. And this is the, we'll just start filling out the information we have. So the plate, if you look, doesn't go to the tube socket. The plate is connected to this cap, which I will affectionately name C for cap. Boom. All right. Now, what do we have next? This is the grid number 2. And if you look here it is here, grid number 2. And grid number 2 is pin 4. So, using my awesome imagination, I'm going to name that pin 4. And now I'm going to go over to the input grid, grid number 1. This is where your signal comes into. And through the power of imagination and stealing the number that's on the pinout chart, I see that grid number 1 is connected to pin 5. I feel like we should be shouting bingo. All right, pin 5. Now let's see, what's the cathode hooked up to? Cathode is hooked up to pin number 8. This is an 8-pin tube socket. Pin number 8. So let's write that down right here. And obviously that's going to get an 8. So now everything we need labeled is labeled. Once again, we don't have to worry about grid number 3 because it is connected to the cathode. So now let's go back to our pointy thing that I love, the select mode. And let's talk about these components external to this tube. So this is going to be the grid resistor, not to be confused with the grid stop resistor. Typically, this is called RL. And this determines the AC load line. But we are not going to get into that. Not today, anyways. So this is our cathode. And this is typically referred to as RC. Or I'm sorry, RK. If you look here, you'll notice that the cathode is a very special component. And this is probably going to be our most looked at thing. When we're talking about setting up an operational point for the tube, we're really talking about what are we doing here? This is how we bias the tube. And we'll definitely get into that later. Now this little guy, this is a capacitor. And this is going to be annotated as CK. This is the bypass capacitor. And we'll get into how that works. But now that we have everything labeled and everything kind of in place, let's connect it with, let's do some wiring. So go ahead and come up here and select wire mode. All right, I'm in wire mode now. No one stopped me. First thing we're going to do is we're going to connect this transformer. Boom. And you can connect it directly, but I just left some room so that I could see what's going on around it. So now let us wire our input. The cool thing about this wire is you can kind of move it around and just get it where you need to go. Even if you're drunk, still going to work. All right. All of these grounds are going to be connected. So the AC load line or the grid resistance is grounded to this here, the cathode resistor, RK, and CK. And CK, we're just going to draw a line here. CK is a bypass for RK. So what that does, come back to my handy dandy selector tool, as you have signal coming through here, some of that signal gets jammed up and you can get more signal. This actually affects your gain. You can actually get more gain by adding this here, a bypass. And what this does is it becomes resistive to certain frequencies, but allows others to pass. And it's going to let your lower frequencies pass. And they don't have to all go through here. So now, like adding another lane for a highway, you got less traffic congestion. And your tube will operate that much better, giving you more gain. This here, in the next video, we're going to figure out what the load, and we're going to look at a load line. And we're going to do that with this, the VTADIY.com, which I just discovered and I love. So next video, we'll figure out what these components, what they're going to be. what the resistance is going to be, what the capacitance is going to be, what the load's going to be. Except for this, RL. We're going to figure this out right now. By God, let's see here. This one is an easy one. We come to Frank Pocknet, and we're going to keep going back to this, and I'll show you how to use, well, most of this stuff anyways I use. Some of it is not good to us. So I mentioned it's the grid resistor, right? Well, the maximum grid number 1 circuit resistance, they're talking about this bad boy right here, grid number 1, just above the cathode, the input grid. That maximum resistance can be up to 0.47 mega ohm or 470K. So what we do, as far as the AC load line, now I want to design this without getting into the weeds of things. So I'm just going to tell you, whenever I put in RL, any amp you'll see, it is going to be about half of the allotted grid resistance. So the closest, double click on that, the closest value for a resistor that's half of 470,000 ohms is a 220 ohm resistor or 220K. And to put that up there, click OK. And I'm just going to move it over here. And bam, we are done for the day. In our next video, we're going to find this. I'm going to show you what the voltage is going into grid number 2 and the voltage going into this transformer, which then goes into the tube cap. All right. If you liked what I've done, please comment. If you didn't like what I did, you can comment too. I might even comment back to you. It'll be fun. And we'll carry on with our mission to build this little amplifier. And I think it's going to be fun. So can't wait to see how it turns out. And I'll look forward to seeing you on our next video. Have a great day.